Hello friends, now I am explaining the topic on shortest of a serve with preemptive scheduling. In previous video I explained if shortest of a serve on non-preemptive scheduling. Preemptive scheduling means it performs context switching for each and every process. Whereas coming to non-preemptive scheduling, it does not perform context switching. When the process is entered to the queue, it executes once at a time. Today I am going to discuss SJFS on preemptive scheduling. Now this is a process and arrival time burst time is given. Along with 5 processes we have to perform average waiting time and turnaround time. First we will draw the Gantt chart. Initially the process is entered at 0. Among first in the 0 millisecond the P1 is entered as 0 millisecond in the CPU. First give the P1 once at a time and give one burst. After giving one burst for P1, the burst time will reduce it to 1. Now the P1 process will be run up to 4 millisecond. Why means it give one burst for P1. Now it is reduced to 4. Now the P1 is entered for 1 millisecond in preemptive scheduling. Similarly, the P2 process also entered into the CPU. Before entering to this Gantt chart, first to identify the shortest job among P1 and P2. Why means in 1 millisecond only two processes has entered in the CPU. P3, P4 and P5 are not entered into the CPU yet. Among the P1 and P2, P1 has the shortest time, that is 4 millisecond. Again and write the P1 in the Gantt chart and give one burst. Now it will become 2 millisecond. Now reduce the P1 process to 1. Now it become 3 millisecond. Now the P3 process also entered in the ready queue. P4 and P5 has not entered in the ready queue yet. Among P1 and P2 and P3, the shortest job that I executed among these three is P3, that is 1 millisecond. Give P3 to the CPU for 1 millisecond. Now 2 plus 1 will become 3. P3 process is completed. Now don't need to touch P3. In 3 millisecond, P1, P2 and P4 is entered in the ready queue. Among these three, P1, P2 and P4, shortest job among these three is 2 millisecond, that is P4. Give P4 to the CPU and give one burst. Now it will become 4 millisecond. Now reduce P4 process to 1. Now it will 1 millisecond. Why 1 is subtracted means it give one burst to the CPU for each and every process. Similarly, P5 is also entered in the ready queue. Now all the processes are entered in the ready queue. Now among these 4 processes P1, P2, P4 and P5, P4 again has a shortest job 1 millisecond. Give 1 millisecond to the CPU and give one burst, that is 5 millisecond. P4 job is completed. Now remaining processes are P1, P2 and P5 process. Among these three, now no need to perform any context switching. Now it is finished. Once we entered to the 4th millisecond, now the context switching will get finished. Now we'll move on to normal shortest of first scheduling. Now among P1, P2 and P5, P1 has the shortest job, that is 3 millisecond. Give P1 to the CPU and execute 3 millisecond. Now 5 plus 3 will become 8 millisecond. Now the P1 job is also completed. Concentrate on P2 and P5. Among P2 and P5, P5 has the shortest job. Now execute for 8 millisecond. Now it will be 16 millisecond. P5 job is also completed. And the remaining process is P2. Assign P2 to CPU and run for 9 millisecond. Now it become 25 millisecond. This is the actual process for the Gantt chart. Now let us calculate waiting time and turnaround time for each and every process. Now the waiting time is denoted with the formula starting time minus arrival time. We have to calculate waiting time for each and every process. Coming to the waiting time for P1, the starting time is 0 millisecond and the arrival time is also 0 millisecond. Now the students will confuse that where to take and this will be neglected. That is wrong. Starting time is 0 millisecond. Now the arrival time is also 0 millisecond. And next here is also P1 is there. From 5 millisecond to 2 millisecond the process P1 has waited. Now subtract 5 millisecond with the 2 millisecond. Are you understanding? Like starting time is 0, wait arrival time is also 0 for first burst, and similarly for the second burst the P1 is executed two times. The starting time, the P1 entered the process for the second time is 5 millisecond, and the process P1 ended for the first process is 2 millisecond, that is executed for 3 millisecond, that is waited 3 millisecond totally. Similarly for the process P2 does not perform any context switching. Directly we can subtract with the starting time minus arrival time. 16 minus 1 become 15 millisecond. Similarly for the process P3 also didn't get any context switching. Directly we can subtract. Starting time is 2 millisecond, arrival time is also 2 millisecond. Now it will be 0 millisecond. For the process P4 doesn't perform any context switching. The starting time is P4 is 3 millisecond and the arrival time is also 3 millisecond. Now it will be 0 millisecond. Similarly for the process P5 also didn't perform any context switching. For the P5 the starting time is 8 millisecond and the arrival time is 4 millisecond. The total is 4 millisecond. Now let us calculate total waiting time. Now the total waiting time will be 22 millisecond. Average waiting time is 22 by 5. It will be 4.4 millisecond. Waiting time is average waiting time is calculated. Now let us calculate turnaround time for each and every process. Turnaround time is defined as waiting time plus burst time. Now let us calculate turnaround time for each and every process. This is simple, just like substituting each and every waiting time and burst time given in the table. Let us calculate. For P1 waiting time is 3 millisecond and the burst time is 5 millisecond. Don't take 3. 3 is performed by using the context switching to construct a Gantt chart. Now it will be 8 millisecond. Similarly for process P2, the waiting time is 15 millisecond and the burst time is 9 millisecond. It will be 24 millisecond. For the process P3, the waiting time is 0 millisecond and the burst time is 1 millisecond. For the process P4, the waiting time is 0 millisecond and the burst time is 2 millisecond. See here, 2 is given in the actual question. Do not take 1 millisecond because it performs context switching. Now it will be 2 millisecond. Similarly for the process P5, the waiting time is 4 millisecond and the burst time is 8 millisecond. It will be 12 millisecond. Let us calculate the total turnaround time. Total turnaround time will be 47 millisecond. Let us calculate average turnaround time. It will be 47 by 5. It will be 9.4 millisecond. That is the answer for average waiting time and average turnaround time. If you have any doubts, please drop the message in the chat box. Thank you.